Good morning, students. Today we are going to discuss about types of organic reactions. This is a subtopic of our topic structural theory in organic chemistry. This is the first lesson of second unit, that is organic chemistry for BSc first year, first semester students. Now let's discuss about today's topic. So today's topic is types of organic reactions. All organic reactions are classified into mainly four types. They are first one is addition reactions, second one is substitution reactions, third one elimination reactions, and last one is rearrangement reactions. So these are the four types of reactions which fall into the organic chemistry. So organic reactions, they are all classified into four types: addition, substitution, elimination, and rearrangement reactions. Now let's discuss about few of these reactions in today's class. Okay, first of all, let's discuss about the addition reactions, the first type of organic reactions. Now, what are addition reactions? Let's see. Addition reactions are the reaction in which two atoms or groups are introduced in place of a pi bond. So, the reaction in which two atoms or groups are introduced in place of a pi bond is called addition reaction. So, in any reaction, either two atoms or two group of atoms are introduced in place of a pi bond, then that particular reaction is called addition reaction. This we should remember. Okay. Generally, addition reactions are shown by unsaturated compounds. So, addition reactions are the characteristic reactions of unsaturated compounds. Now, what are unsaturated compounds? Unsaturated compounds are the compounds which contain either double or triple bonds. The compounds with double bonds, the compounds with triple bonds are called unsaturated compounds. And we know many unsaturated compounds which we have already discussed in the previous classes. Alkenes they come under unsaturated compounds, and alkynes also they come under unsaturated compounds. Alkenes are the compounds containing double bonds, and alkynes are the compounds which contain triple bonds. Triple bond, CC triple bond. CC double bond is present in alkenes, CC triple bond is present in alkynes. So these compounds, they come under unsaturated compounds, and these unsaturated compounds generally they undergo addition reactions. Okay, let us say this general reaction. Here we considered an alkene, C double bond C. This is an alkene. To this molecule AB is added. AB is added. Then what happens? A goes to one carbon and B goes to another carbon, and this pi bond breaks. So in the place of pi bond, two atoms or groups are introduced, and this reaction is only known as addition reaction. So this is the addition product or adduct obtained here, and this is an unsaturated compound, that is alkene. This is the reagent. So this is called substrate, this is called reagent, and this is called product. Okay. Now, classification of addition reactions. These addition reactions are classified into three types. Addition reactions are classified into three types. So, based on the type of the reagent which initiates the reaction, the addition reactions are classified into three types. So, what type of reagent is used to initiate the reaction? Based on this, the addition reactions are classified into three types. The first one is electrophilic addition reaction. Second one is nucleophilic addition reactions, and third one is free radical addition reactions. So, electrophilic addition reactions, EARs. This is the abbreviation given. Nucleophilic addition reactions, NAR, nucleophilic addition reactions. And here, free radical addition reactions. Free radical addition reactions. So, Here, addition reactions are classified into three types: electrophilic addition reactions, nucleophilic addition reactions, and free radical addition reactions. Now, let's discuss about each and every type of addition reactions in detail. So, first, let's start with electrophilic addition reactions. So, what are electrophilic addition reactions? The addition reaction in which The addition reaction which involves the initial attack of an electrophile are called electrophilic addition reactions. So, in the electrophilic addition reactions, initially an electrophile goes and attacks the substrate. Because of that reason, they are called electrophilic addition reactions. Electrophilic addition reactions. Now, in this electrophilic addition reactions, the pi bond of alkene, which is susceptible for electrophilic attack are electrophiles because it acts as a source of electrons or it acts as a nucleophile. So here let us consider an example and explain in this. This is alkene, the pi bond, this pi bond, it acts as a nucleophile or this is the source of electrons. So here from the substrate, this is the Hx, this is the reagent Hx, and this is the substrate. So from the reagent Hx, this pi bond or nucleophile, it goes and abstracts the positive part of Hx. Then what happens? This is electrophile and this acts as a nucleophile. The bond is formed in between this carbon and this electrophile. See, a new sigma bond is formed in between this carbon and this electrophile, that is uh, hydrogen atom of this Hx reagent. Then what happens? This substrate, it now becomes a carbocation or electrophiles. You see, carbocation, carbon with positive charge. As this from use with the help of this pi bond electrons, this electrophile H plus, it forms a bond with this carbon. Because of that reason, this carbon, second carbon, next carbon, it suffers with a positive charge. Therefore, now a carbocation or electrophile is generated, and this X, it comes along with this bond pair of electrons as X minus. X minus. So this is the first step. In the first step, electrophile, this electrophile, it is getting added to the doubly bond, one of the doubly bonded carbon atoms. Because of this reason, this is known as electrophilic addition. So here addition of electrophile is taking place. Therefore, it is called electrophilic addition reaction. So this hydrogen halide, this is the reagent, and this hydrogen halide, it reacts with alkenes by donating a proton to the pi bond. Donating a proton to the pi bond. So proton or H plus acts as an electrophile here, this one, and hence attacks the pi bond to form a new sigma bond. To form a new sigma bond with one of the carbon atoms. Here we are showing with this carbon atom. Okay. So this leaves a vacant orbital and a positive charge on the other carbon. So this carbon is having a vacant orbital and the positive charge because it is surrounded by only 3 bonds. Therefore, it gets a positive charge. The overall reaction is the formation of carbocation or an electrophile. Carbocation and electrophile along with a halide ion, that is X minus ion from the alkene and HX. So this alkene combines with HX to form a carbocation and halide ion are produced here. So in the next step, what happens? This electrophile or carbocation, this carbocation, it combines with the halide ion by accepting a pair of electrons. It has an extra electron pair, minus charge, that is. So accepting this electron pair to form the final product. So in the final product, to the pi bond that is present in between the two carbon atoms is broken, and two new sigma bonds are formed to this alkene, forming a product that is halide. Alkyl halide is produced here. So an alkene combines with HX to form an alkyl halide. Alkyl halide. So in this reaction, H goes to one carbon atom and X goes to another carbon atom, and the pi bond present in between the two carbon atoms is broken. So this is an addition reaction where the addition is initiated by an electrophile. Therefore, it is called electrophilic addition reaction. So this is about the electrophilic addition reaction. General example here we discussed. Now let us consider the specific example. Specific example: addition of HBr to ethylene. Addition of HBr to ethylene. Here, ethylene is the nucleophile. Nucleophile, that is a source of electron pair or a source of pi bonds. This combines with HBr. With the help of this pi bond, this H plus, that is an electrophile, it combines with this to form an electrophile, that is carbocation, and Br minus ion. The next step for this carbocation, it combines with Br minus ion. You can see here electrophile, that is this one, carbocation plus Br minus, to form the final product, alkyl halide. This is ethyl halide. Ethylene combines with HBr to form ethyl bromide, the bromoethane. This is the final product obtained. This is an electrophilic addition reaction. Now let us see the second type of addition reaction, that is nucleophilic addition reaction. Nucleophilic addition. What are nucleophilic addition reactions? Let us see. The addition reactions which involve the initial attack of nucleophile are called nucleophilic addition reactions. So, in these addition reactions, initially a nucleophile goes and attacks the substrate. Then they are called nucleophilic addition reactions. Is it okay? So, this type of reactions are most common in carbonyl compounds. So, in the carbonyl compounds, we can come across nucleophilic addition reactions. They are the characteristic reactions of carbonyl compounds. So what are carbonyl compounds? Aldehydes and ketones are known as carbonyl compounds. Okay. Now let us see an example. Here, addition of HCN2, an aldehyde. This is acetaldehyde. To this addition of hydrogen cyanide. This reaction let us discuss here as an example for nucleophilic addition reactions. So in the addition reactions of carbonyl compounds are quite opposite to alkenes because the polarization of the pi bond. So in the carbon atom of a carbonyl compound is positively charged. This one, carbon atom of carbonyl compound is positively charged, and that of oxygen is negatively charged. See, partial negative charge on oxygen, partial positive charge on carbon due to polarization of the bond, because oxygen is more electronegative when compared to carbon. Okay, oxygen is more electronegative when compared to carbon. So carbon has partial positive charge, oxygen with partial negative charge. Then what happens? The this In this aldehyde, this carbon, it acts as an electrophile. Now from this HCN, this is the reagent. This is in the form of H plus and Cn minus ion. Cn minus is the nucleophile, negative ion, nucleophile. This negative ion, that is cyanide ion, it goes and attacks this carbon atom because carbon is here having partial positive charge due to bond polarization. Okay, then what happens? It goes and attacks this carbon and it forms a sigma bond, a new sigma bond with this carbon atom. So, a new sigma bond is formed in between the carbonyl carbon of this acetaldehyde and cyanide ion. Okay, so the next step, what happens? This ion, oxyanion, is which is produced here. It abstracts a proton because this oxygen is having a negative charge. It abstracts a proton from HCN, that is the reagent molecule, to form the final product. This is the final product obtained. So here overall reaction is addition reaction, where the addition is taking place in between C and O. This one, C double bond O. Here this pi bond is broken and two new sigma bonds are formed. One is with the Cn and the other one is in between this oxygen and hydrogen. A new sigma bond is formed. So this is called cyanohydrate. This is obtained from acetaldehyde. Therefore, it is called acetaldehyde cyanohydrate. So acetaldehyde, it undergoes addition with hydrogen cyanide to form acetaldehyde cyanohydrate. This is the reaction where the nucleophile initially goes and attacks carbonyl carbon. Therefore, it is known as nucleophilic addition reaction, because finally we will get an addition product. So, this is addition of HCN to acetaldehyde. HCN is a weak acid and it is ionized to a small extent, resulting in the formation of cyanide ion and a proton and cyanide ion. Okay. So the cyanide ion is nucleophile and it attacks carbonyl carbon. The cyanide ion is nucleophile, it attacks carbonyl carbon or electrophilic carbon. This one, electrophilic carbon of acetaldehyde, resulting in the formation of oxyanion. This oxyanion, which oxyanion in turn reacts with HCN, another molecule of HCN, and abstracts a proton. Okay, abstracts a proton, and the concentration or number of HCN molecules is more compared to H plus ions. Hence, the oxyanion reacts with HCN instead of a proton. So, a cyanide ion is formed which initiates the new reaction. And here from this, a cyanide ion is formed which initiates the new reaction. Okay, so these steps can be given in this manner: 1, 2, and 3. Okay, finally we will get acetaldehyde cyanohydrate as a product. So here, this is about nucleophilic addition reaction. Now let us consider another reaction, that is free radical addition reaction. So free radical addition reaction. So these are the addition reactions which involve the initial attack of a free radical. Therefore, they are called free radical addition reactions. Okay. Now, let us see the example for this. Example. So, in the free radical addition reaction, the addition reaction is initiated by a free radical. And here we are considering addition of HBr to propene. Addition of HBr to propene. This one. Propane CH3 CH double bond CH2. This is propane. Here we are adding HBr. This is a reagent. This is the substrate. Okay. HBr to this propane. So addition of HBr to propane in the presence of peroxide is the best example for free radical addition reaction. Okay. So this is all in the absence of peroxide, the addition would be electrophilic. Therefore, in presence of peroxides only, free radical addition takes place. Therefore, this is known as peroxide effect. So the addition proceeds via free radical formation. So in the first step, what happens? The unstable peroxides are decomposed readily to produce this one, peroxide, decomposed readily to produce alkoxy free radical, RO dot. Okay, alkoxy free radical. And they in turn abstract hydrogen. This alkoxy free radical abstracts hydrogen from HBr to form ROH alcohol and Br dot, that is bromine free radical. Br dot, that is bromine free radical. Okay. And this is in this what happens, this is a chain reaction, this goes like this. And the reaction, in this reaction, what we can show it like this. So this is peroxide in presence of that is H nu, that is light. It decomposes to form alkoxy free radical. This alkoxy free radical abstracts proton from HBr to form ROH and Br dot, that is bromine free radical. This bromine free radical goes and attacks the carbon atoms of a double bond of propene. Then we will get what is this is alkyl bromide radical is obtained here. This alkyl bromide radical is obtained, and this alkyl bromide radical which abstracts proton from HBr to form the final product as 1-bromopropane. 1-bromopropane. Okay, so this is the free radical addition reaction, where the addition reaction is initiated by a free radical, and how a free radical is obtained from a reagent is because of the peroxide. In presence of peroxide only this free radical addition takes place. Therefore, this is also known as peroxide, we said. Okay, so this is the best example for free radical addition reaction, that is addition of HBr to propane in presence of peroxide. In presence of peroxide. So the next reaction, in addition reactions, three types we studied, that is electrophilic addition reaction, nucleophilic addition reaction, and free radical addition reaction. And let's discuss about substitution reaction, second type of organic reactions, that is substitution reactions. So substitution reaction is one in which a substituent, that is either an atom or group, replaces another substituent, that is an atom or group. So substitution reaction is the reaction in which uh, a substituent replaces another substituent. Okay, so the substituent may be an atom, maybe group of atoms, like that. So here the substitution reactions are characteristic reactions of generally saturated compounds, whereas addition reactions, we said already, they are the characteristic reactions of unsaturated compounds. Big, but here substitution reactions are the characteristic reactions of saturated compounds like alkanes, alkyl halides, and aromatic compounds. Generally, aromatic compounds, they will be having double bonds, but they are unsaturated compounds, but they behave like they are saturated compounds by undergoing substitution reactions. Okay, so here general substitution reaction we mentioned. General substitution reaction, where this is the substrate Rx, this is Y is the reagent or substituent. Let me say this substituent, it goes and replaces another substituent from the substrate. So Y goes and replaces X. Then what is the product obtained? Or Y is the product obtained and X comes out. This is the leaving group, let me say. So this is the best example for substitution reaction, general example for substitution reaction. Now next, let's see classification of substitution reactions. Substitution reactions are classified into three types. Similar to addition reactions, they are also classified into three types. There, the first one is electrophilic substitution reaction, second one nucleophilic substitution reactions, and third one free radical substitution reactions. So electrophilic substitution reactions ESR, nucleophilic substitution reactions NSR, NSR abbreviation, and free radical FRSR. So free radical substitution reactions. So substitution reactions are also classified into three types. What are they? Electrophilic substitution reactions, nucleophilic substitution reactions, and free radical substitution reactions. Now let's discuss about these three types of substitution reactions in detail one by one. So first of all, let's discuss about electrophilic substitution reactions. Electrophilic substitution reactions. So the substitution reaction in which electrophile replaces another electrophile from the substrate molecule is called an electrophilic substitution reaction. So in this, one substrate replaces one substituent replaces another substituent. We said in substitution reaction. So here, if the substituent is the electrophile, then it is known as electrophilic substitution reaction. That is, in substitution reaction, one electrophile replaces another electrophile from the substrate. Okay, now let us see the example. Here, benzene. Say 6H6 benzene. When it is treated with an alkyl halide RX in presence of anhydrous AlCl3, that is a Lewis acid, then we will get, if this is R, we get CH3 here. Okay, this R is CH3X. If this is CH3X, we get CH3 over here. Otherwise, R. Okay, general reaction R we can write, or if it is CH3, we can say that it is CH3. So this is the molecule obtained. This is called toluene. Toluene. So when benzene is treated with methyl halide in presence of anhydrous AlCl3, we will get toluene. So in this reaction, what is that happening is, this from Rx, R is the nucleophile. Sorry, from the Rx, R is the electrophile, and this electrophile, it goes and replaces H, one of the hydrogen atoms of benzene, to form a product. To form a product. So this, in this reaction, benzene is a nucleophile because it has 3 pi bonds, because it's an it has 3 pi bonds, that is, it is an electron excessive species. That is pi excessive species, and the pi bonds are more. So pi electron cloud is above and below the plane of the benzene nucleus. So electrophilic reagents, this like this methyl group or alkyl group, electrophilic reagents readily attack benzene ring or benzene nucleus, thereby this electrophile, it replaces hydrogen ion or proton from benzene. So these electrophilic substitution reactions essentially proceed through three different steps. They are, first step is generation of electrophile from this, that is the reagent. It gives the electrophile. And second step is attack of electrophile on the aromatic nucleus, producing aranium cation, and the removal of proton with or without the assistance of a base. That is the third step. So these are the three stages involved. In the first step, this from this reagent, an electrophile is generated, that is R plus is generated. In the second step, this R plus goes and attacks benzene nucleus to form an aranium cation. In the third step, this aranium cation, it loses a proton, it loses a proton to form the final product. These are the three steps involved in the electrophilic substitution reaction. So the electrophilic substitution reaction is the reaction in which one electrophile is replaced by another electrophile. So the electrophile present in the substrate molecule is replaced by electrophile present in the reagent molecule. Then we will get the final product, that is substituted product is obtained. Okay, now let us see the next type of substitution reaction, that is nucleophilic substitution reaction. Nucleophilic substitution reaction. So what is a nucleophilic substitution reaction? This is the substitution reaction in which one nucleophile replaces another nucleophile from the substrate molecule. So the nucleophile present in the reagent replaces the nucleophile present in the substrate to form a substituted product. This reaction is known as nucleophilic substitution reaction. So the best example for nucleophilic substitution reaction is base catalyzed hydrolysis of ethyl bromide. Base catalyzed hydrolysis of ethyl bromide. That is, ethyl bromide is hydrolyzed in presence of a base. Okay, So in this base catalyzed hydrolysis of ethyl bromide, OH minus ion is the attacking nucleophile and Br minus is the leaving nucleophile. So Br minus is present in ethyl bromide, that is it is present in substrate, and OH minus is present in the base, that is the reagent. So OH minus is attacking nucleophile and Br minus is the leaving nucleophile. Now let's see the reaction. Here OH minus of the base, it goes and attacks this substrate. Then what happens? We will get a new sigma bond formed in between this nucleophile of the reagent and the carbon atom of the substrate. Then we will get a new bond formed in between this carbon and OH. See, this is OH minus ion. This is the attacking nucleophile. It attacks this carbon. Then what happens? This Br along with this pair of electrons in the form of Br minus, it is leaving. Hence it is leaving nucleophile. This is attacking nucleophile. OH minus attacking nucleophile, Br minus is the leaving nucleophile. So one nucleophile, it substitutes another nucleophile. Therefore, it is nucleophilic substitution reaction. So these nucleophilic substitution reactions are based on how does the nucleophile replace the leaving group? How does the reaction takes place in one step or several steps? Which steps are slow and which steps are fast? The rates of chemical reactions or the kinetics of the reactions, they explain all these. So, alkaline hydrolysis of ethyl bromide here we studied. So, in presence of a base that is a strong base like NaOH or KOH, etc., then what happens? This ethyl bromide, it undergoes hydrolysis to form ethyl alcohol. Ethyl alcohol. So, this is the best example for nucleophilic substitution reaction. Uh, let's discuss about the other type of substitution reaction, that is free radical substitution reaction. So this is the last one in the substitution reactions, that is free radical substitution reaction. So what is free radical substitution reaction? Let's see. So free radical substitution reaction is the reaction in which a free radical replaces another free radical from the substrate. So the free radical of a reagent replaces another free radical from the substrate molecule, and this reaction is known as a free radical substitution reaction. So the best example for free radical substitution reaction is chlorination of methane. Chlorination of methane is the best example for a free radical substitution reaction. And this reaction, it takes place generally at high temperature or in the presence of sunlight. High temperature or in presence of sunlight. If we consider this reaction, this is methane. It combines with chlorine in presence of sunlight. Delta means heating or high temperature, heated to high temperature or in presence of sunlight. Then what happens? One hydrogen atom is replaced by a chlorine atom to form methyl chloride, and other product is HCl. So in this reaction, what happens? Uh, one free radical, that is H hydrogen free radical, is replaced by chlorine free radical. Then we will get methyl chloride as the final product in this reaction, plus HCl is also obtained. A heat or light promotes this reaction. Heat, see, chlorination of methane at high temperature and presence of sunlight research. So heat or light promotes this reaction. At room temperature, methane and chlorine do not react. So if the gaseous mixture is irradiated with UV light or at high temperature, they react to give the methyl chloride. Okay, so the light promoted reaction is highly efficient and small number of photons converts the reactants into products almost completely. So these observations must be explained by the mechanism proposed for this reaction. So that mechanism, from that mechanism only we will come to know that it is free radical substitution reaction. So in the first step, chlorine molecule is fragmented. This chlorine molecule is fragmented into two chlorine atoms. Two chlorine atoms are produced. Okay. This reaction takes place in presence of light or heat because it is an endothermic step. In the second step, the chlorine atom, it abstracts hydrogen from the second step, the chlorine atom, it abstracts one hydrogen atom from methane molecule to produce methyl free radical. CH3 dot is produced in the second step. Okay, to produce methyl free radical. The highly reactive methyl free radical reacts with one chlorine molecule resulting in the formation of chloromethane, methyl chloride plus another chlorine free radical. So the chlorine atom or chlorine free radical may attack methane molecule, which is repetition of step 2. Step 1, chlorine Cl2 undergoes fragmentation into two chlorine atoms. Second step, one chlorine atom, it abstracts one hydrogen atom from methane to form methyl free radical and HCl. In the next step, what happens? This methyl free radical, it combines with chlorine molecule to form methyl chloride and chlorine free radical. So the second and third steps, they are repeated. So they are repeated. Second step, what is that happening in the second step? Chlorine free radical combines with methane and extracts one hydrogen atom from methane to form methyl free radical. This is the second step. In the third step, what happens? In the third step, methyl free radical combines with chlorine molecule to form methyl chloride and chlorine free radical. So, second and third step. So the chlorine atom may attack methane molecule, which is a repetition of step 2, resulting in the formation of methyl radical. Then step 3 is repeated and so forth. So for hundreds and thousands of times, these two steps are repeated. That is 2 and 3 steps, in which one radical generating another radical, resulting in the formation of the product. And these two steps are known as chain propagation steps. So this type of repetition of second and third, etc. That is second and third, second and third, second and third, etc. In cyclic order in a reaction is known as chain reaction. So chlorination of methane is a chain reaction. So step 1 is chain initiation step, step 2 and 3 are propagation steps, and last step is chain termination step. In the chain termination step, what happens? One methyl free radical combines with a chlorine free radical to form methyl chloride, that is chain termination. Or in the other in second, another type of chain termination is also possible, where one methyl free radical combines with another methyl free radical to form ethane. This is also chain termination, one of the chain termination steps. And last chain termination step is one chlorine free radical may combine with another chlorine free radical to form chlorine molecule. There also the termination of the chain takes place. So uh, in this way, the chlorination of methane takes place. So along with chloromethane, this is chloromethane or methyl chloride, other highly chlorinated products like CH2Cl2, CHCl3 and CCl4 are also formed. So with this free radical mechanism also explains the formation of all these molecules. Okay. And about this reaction mechanism and all, we will discuss in the next semester. Therefore, here we will stop it with um, just only main reaction of chlorination. Okay, and then till now we have discussed about types of organic reactions. There we discussed about we have four types of organic reactions. The first one is addition reaction, second one is substitution, third one is elimination, fourth one is rearrangement reactions. So today we discussed about addition reactions and substitution reactions. Okay, so how many types of addition reactions? Addition reactions we discussed about three types. Let us see three types of addition reactions. The first one is electrophilic addition reactions. Second one is nucleophilic addition reactions. Third one is free radical addition reactions. So three types of addition reactions we discussed. And next, about each and every type we discussed in detail: electrophilic addition, nucleophilic addition, and free radical addition reactions with examples. Electrophilic addition reaction, which is initiated by electrophile, and electrophilic addition reactions are the characteristic reactions of unsaturated compounds where CC double and triple bonds are present with it. And nucleophilic addition reactions, these are the characteristic reactions of aldehydes and ketones, that is carbonyl compounds, where the reaction is initiated by a nucleophile visit. Example also we discussed. And the third one is free radical addition reaction. And free radical addition reactions are the characteristic reactions of alkenes in presence of peroxides, we said. Example we have given: propene, it combines with HBr in presence of a peroxide to form 1-bromopropane as a major product. And next type of reactions, substitution reactions and the organic reaction. Second type is substitution reaction we said. And the substitution reactions are also for three types we said. One is here electrophilic substitution reaction, second one nucleophilic substitution reaction, third one is free radical substitution reactions. There we discussed about electrophilic substitution reactions, where the substitution reaction in which one electrophile substitutes another electrophile of the substrate. Example, generally aromatic compounds, they undergo electrophilic substitution reactions, especially benzene, it undergoes electrophilic substitution reactions, where an electrophile of the reagent, it substitutes hydrogen atom of benzene ring in presence of a Lewis base like anhydrous AlCl3, etc. And next one is nucleophilic substitution reactions. And these are the generally nucleophilic substitution reactions are the characteristic reactions of alcohols, alkyl halides, etc. Where here example we discussed alkyl halide, that is ethyl bromide. It undergoes hydrolysis in presence of a base to form alcohol. So this is the example we have given, where OH minus is the attacking nucleophile and Br minus is the leaving nucleophile, we said. And last one is free radical substitution reaction. In free radical substitution reaction is the reaction in which a free radical replaces another free radical from the substrate molecule. And here we discussed the example, that is the best example for free radical substitution reaction is chlorination of methane. This chlorination of methane, it takes place at high temperature or in presence of sunlight, we said. So there it is a chain reaction. In this chain reaction, first step is chain initiation reaction, second step is chain propagation, and third step is chain termination reaction. Where in the chain initiation reaction, a chlorine free radical is obtained. In the chain propagation reaction, methyl free radical is obtained, which combines with the chlorine molecule to form methyl chloride. And these two steps are repeatedly taking place, and hence it is known as a chain reaction. And finally, the last step is chain termination reaction, where two free radicals combine to form the final product. Then, thereby, the chain propagation stops. So, these are the three stages involved in the chain reaction, that is in the chlorination of methane, which takes place by free radical mechanism. Okay, now let's stop it here, and we will continue in the next class with the remaining types of organic reactions, where we are left with the two more types of reactions. One is elimination reaction, uh, last one is rearrangement reactions. So we will discuss about elimination reactions and rearrangement reactions in the next class. Okay, thank you.